Note, everything that you hear and see and hear is all been researched by me. I know some of you might not consider this as a machinima, but this is more meant to be an informational video. Enjoy. Hey guys, Maniac here with my Mix and Flow machinima. Now, today we're going to be doing WHMIS, which is Workplace Hazardous Materials. First, for the symbols that I'm going to be talking to you about is biohazard, which is something that is poisonous, like a needle. It can cause bacteria-related illness, and yeah, so such as this poison bottle. We'll take this as a needle. Next, we have compressed gas. Compressed gas is gas that has been compressed into a container, and if the container has been compromised by any sort, it will explode. Next, we have corrosive material, which is, I'll use this lava, which will melt your skin basically. It melts through anything. Next, we have poison, which is usually in any contact, mostly relating when you swallow it, you will get poison, and as you can see, I'm now poisoned. See, poison, and yeah, that also counts for toxic. That's the same thing. Next, we have flammable. Flammable is basically fire. Anything that is easy being able to catch on fire. So I'll just drop down here, and as you can see, this grass is very flammable. Anyways, next we have oxidizing. Oxidizing is something that basically in high heat will help ignite a fire. And then, which is this. And then we have dangerously reactive material. So take this. So we have basically something that reacts strongly to another material. As you can see, this water reacting quite strongly to that lava. For an example. Alright, so that's it for WHMIS, and next slide. Hey guys, I'm here with some states of matter in Mix and Flow as we watch the sun rise. So, there are 3 states of matter. We have liquid, solid, and gas. Each one can turn into each other or turn, yeah, basically that. There's melting, sublimation, evaporation, condensation, and finally freezing. Freezing is a liquid going into a solid. Condensation is a gas going into a liquid. Evaporation is a liquid going into a gas. Sublimation is a solid going into a gas. And melting is a solid going into a liquid. So it is as easy as that. So, on to the next lead, Maniac Cheese Wankers. Blah.
The power invested in me by the giant bones bird. The president shall not be the shiniest of 2 turds.
Hello again, it's nice to see you state for a particle model of matter. Particle model is quite simple actually. It is a model of particles in each state of matter, saying that solids particles are compact. Liquids are a bit spread out and fast, and gas is everywhere and really fast. To give an example, I have a dumbed down version of the particle model. Ice is very compact and does not move that much. The water is flowing and is more spread out in the little container of ice. The gas, well, the gas is basically everything, so that everything you see outside of this. Alright, now that we are done with that, Next slide, Chase Wanker Poop.
And sing this one with me. Are you ready? Here we go.
Hey guys, wow, you're still here? Well then, let's continue then with properties of fluid. Fluid or liquid is caused by pushing and pulling forces underground. Liquids come in different forms and density. Some liquid when poured in a container together will layer because of their densities. There is not much more to it than that, except that fluid will take form of its container no matter what, and if it's not in a container, it just spreads out as you can see here. Alright, well, that's it, and you all know if you've stayed this long what I'm going to say. Nuclear derp.
Every day, every night, I am gonna fight to win. We kicking it.
Hey guys, holy cheese wanker, you guys must be pretty pleased with what you've seen to still be here. Well, my next topic is viscosity and flow rate. So I really have no idea what I was going to use. So I'm just going to read what I got for my research. Flow rate increases as viscosity decreases for a given pressure. Think of squeezing honey, a higher viscosity liquid, out of a honey bear inside of squeezing a honey bear filled with water. The water will flow much easier. The honey will flow slower, but get faster if you stick it in the microwave and heat it up easier. The honey will flow slower, but the honey decreasing the viscosity. Sorry I couldn't find a way to represent this one, but there is always the next slide.
To my house, my house, my house. Take a trip to my house.
Hello my maniacs, this is Bane with more mixing. Oh Bane, get out of my machinima. When your channel is in ashes, then you have my permission to record again. Oh god, do I have to get Bertha again? No Bertha, no Bertha. Bane will be leaving now. Have fun as Maniac explains categorization of matter. Thank you. Alright, so categorization of matter is different materials in a chart. It goes matter, then two split off that, pure substances and mixtures. Each one of those splits off two more branches. For pure substances, it's elements and compounds. Then for mixtures, it's homogeneous and heterogeneous. A pure substance or chemical substance is a material that has constant composition, is homogeneous, and has consistent properties throughout the sample. An element is something on the periodic table, like gold. A compound is two pure substances combined. A mixture is something made of two or more pure substances. A homogeneous mixture is uniform, which means that any given sample of the mixture will have the same composition. Air, sea, water, and carbonation dissolved in soda are all examples of homogeneous mixtures or solutions. No matter what sample you take from the mixture, it will always be composed of the same combination of phases. Chocolate chip ice cream is not homogeneous. One spoonful taken might have two chips, and then another spoonful might have several chips. Another example could be milk. A heterogeneous mixture is not uniform. Different samples may have different compositions. Like the example of chocolate chip ice cream. Sorry for slurring my words and everything. Soil, blood, and salad are all examples of heterogeneous mixtures. So that is it for categorization of matter. Well, I guess I keep saying this, but nextly the slide. Hey guys, Maniac here with some more mix and flow. Now I'm going to be talking about solutes and solvents. A solute is a solid that is dissolved in a liquid. The solvent is the liquid which something is dissolved in. So to simplify it for you, imagine that there is a solute walking along and then it gets grabbed by a solvent and hugs the solute really hard. While it hugs the solute, the solvent is absorbing the solute. Well, that is it for solute and solvent, so I guess I will see you in about 5 seconds in the next slide of epicness, cheese wanker pie. Why hello and welcome back for rate of dissolving. Rate of dissolving is how fast a solute can dissolve in a solvent. If a solute is stirred, it will dissolve faster. If you increase the temperature, depending how you want to say it, of the solute, it will dissolve faster. Both of these are because you are spreading you are speeding up the particles, increasing the rate of dissolving. It also matters how big the particles are. If they are big, it takes longer, but if they are small, it goes faster. That is it, and we are on to the next layer. Hey guys, and welcome to the math portion of the machinima. Yeah, I know, it's science, not math. Well, for some of mix and flow, there is calculations that need to be done. So basically, there are 6 calculations if you want something. The first 3 are mass, density, and volume. To find volume, you multiply mass and density. For mass, you divide volume and density. And for density, you multiply mass and volume. The next 3 are volume, concentration, and moles or grams. To find concentration, it is multiply mole and volume. For moles, divide concentration and volume. Alright, I will now explain concentration in case you're wondering. Which now we're going on to science again. Concentration is how much solute is in a solvent, or at least that is the short version. Now I will commence transition to next day. Hey guys, I'm here with stability and separate points for mix and flow. So we will start with solubility. Solubility is defined as the consistency that can dissolve the solvent. Not all that is really for solubility, but we still have the problem of saturation. Saturation point is the stage at which no more of a substance can be absorbed into a liquid or a solution. Alright, so that is it. I will apologize that I did this as really big talk while you look at my awesome face or around. But some of this went through the game. I have much that change in the next year.
I take your life with such ease, and it's not the way I planned it, but I'm stuck with this disease.
Why hello there maniacs, welcome to buoyancy of mix and flow. The definition of buoyancy is the ability or tendency to float in water or other fluid. Buoyancy happens because of how dense something is. A boat is made of metal / wood, but the hull has air in it, making it less dense than the water, making it float. What makes an object buoyant is the density. If the density is less than the water, it will float. So that is it for density and buoyancy. Yeah, buoyancy. Well, we are almost done, but we still have the next slide.
First in the verse, feel the clack of wooden teeth. Bread and butter, lift the covers while you find the fucking heat. Revolution.
Well, hello there, people who are still watching this video. I'm here with mass, volume, and their relation to density in mix and flow. So, volume is how much something weighs, but will change if you say go to the moon. Mass is basically how you look or how much of something there is. That doesn't change. For example, if you were to say, like I said, go to the moon with an elephant, it would become like a pound, but it would still look the same. It would never change. Its mass would not change. And the relation to density is mass and volume equal up to density. The way you find density is volume multiplied by mass equals the density. So I helped you out with volume, mass, and density. But more to explain in the next slide.
Dig in Minecraft style. Minecraft style. Dig, dig, dig.
Yo guys, I'm here with hydraulics, pneumatics, and pressure/compression. So, hydraulics is basically is basically pressure that has been compressed, and then when you switch a lever like this, poof, a reaction happens and something usually pops up. Pneumatics is the branch of physics or technology concerned with the mechanical properties of gases. Pressure's just pressure, not peer pressure, not like social pressure or but pressure as in compressed gas, and compression's just something bunched up together in a very tight place, kind of like pressure. So that's really it for hydraulics, pneumatics, and pressure/compression, but we still have 2 more slides to go. So next slide, America! Maniacs, I'm back with some more mix and flow. This time I'm going to be talking about separation of solutions. So it is exactly what it sounds like. It's separating solutions. So basically what that means is you're taking so say crunchy brand peanut butter, where you have the peanuts and the peanut butter, and they're all combined, and there's the peanut and the peanut butter and the date. It's basically like taking out all the peanuts in there and just having like a pile of peanuts that was in the peanut butter crunchy, and then the peanut butter on the other side. So I have a cauldron here with water in it, and I'll take some of that water. Alright. Sucked it all up as I was taking it, and I'll just yeah. So basically I just imagine I separated the water from the cauldron. It was kind of being stupid. The game was being stupid. So I can show you guys what I want to show you guys. So, yeah. Alright. We're on to our final slide. So, one of my favorite words. Next slide. YOLO guy, that's me here with my very last slide. Devices and technology that use fluids for mix and flow. Very last slide. So let's get right into it. So devices and technology that use fluids. Well, there's a big list of them, and usually how they use it is there's a processor that they go through. Usually it's steam powered if it involves water, or it's or it's a water pump, or etc, etc, etc. So you have cars that use gas. You have this cauldron here, which they would have used in olden times to boil stuff and everything. You have a kettle, and a boat, you could also say, because without fluids it can't do anything, and plus of the gas it usually needs, depending on what type of boat we're talking about. So really, guys, that is it for this machinima. So really, I would like to thank you guys for watching. If you watch this long, don't forget to subscribe, favorite, like, and all that fun stuff, and I'll see you guys next time, whatever I make. It is gonna dragon. Peace out. Boop.